Okay, we're looking at our next lesson, which is solving systems using either elimination or substitution. So what a system is, it's just basically two equations. And we're looking at the point where these things kind of intersect is really what this is all about. So if we have just two lines, maybe something like 3x minus y equals 4 and x plus y equals 8. So this is a line and the other thing's a line, so we have two lines. We want to find the solution, which means where do these things intersect? And we can totally make that happen. Substitution involves taking one formula and putting it in to the other. And I'm going to show you how that works. When you get your question, you're going to have two lines and you're going to have an x and y in the top one and an x and y in the bottom one. The best way to do this is find which variable is the easiest to isolate for. Now, we're in good shape here because both x and y are all by themselves. So this one's really easy. We can pick either one to isolate for. So I'm going to isolate for y right now. And here's how we do that. So when we isolate for y, we just need to pull that x over and make it all by itself. So we're going to end up with y equals 8. That positive x is going to become negative x, so you get 8 minus x. So we have one equation up here, and we've just rearranged that other one to make our second equation here. So now what we're going to do is we're going to take that y and we're going to substitute it, that's why they call it substitution, in for that y value. So we used to have 3x minus y equals 4, but now what we're going to do is we're going to take that and substitute it directly in for that y value. So we have 3x minus, and now instead of y, we're going to write whatever y is equal to. So that's all this stuff over here. So we're just going to put that in brackets. 8 minus x equals 4. Whenever you substitute, you must use brackets. And you'll see why in just a sec. So we have 3x minus 8 minus x equals 4. Now we just need to solve it for x. So 3x, this minus sign is actually going to get distributed in to each thing, if you remember back to our first lesson about the distributive property. So 3x minus 8, and then that minus is going to get distributed into that negative x and turn it to positive x. So 3/8 plus x equals 4. Now just collect our like terms. So we have 3x plus x, and then we'll move that minus 8 over, equals 4. That minus 8 is going to get dragged over here. It's going to become positive 8. So we have 4x equals 12. Divide this side by 4, divide this side by 4, and you get x equals 3. Good. So now we have the x coordinate of whatever it is we are trying to solve for. But we do not have the y. So how do we do that? Well, now we can take this and we can substitute this x equals 3 back into equation 2 or into equation 1 and then just solve for y. Now, it's definitely to put it easier, or it's definitely easier to put it into this one because y is already by itself, so you don't have to do any rearranging. So what we're going to do is we're going to do that. Y equals 8 minus x, y equals 8 minus, and our x value is 3, so I'll put the 3 in there. So we get y equals 8 minus 3, which is 5, and we have solved it. We've found the solution to be x is 3, y is 5. So that is the solution, or our intersection, between these two lines. So let's take another example of substitution. Okay, let's look at maybe a little bit of a more complicated one. Let's see if I can find a good one here. Oh yeah, let's use this one. 2x minus 3y equals negative 12. And then we have 6x plus 5y equals negative 8. So here's our next one. So what we're going to do here is we want to try to isolate and solve, but the problem is every single one of these variables has a coefficient that's not just a 1. Like before, it was nice and easy. We could have picked any one of these three to make it happen, but here it's a little bit tougher. So in that case, I think the 2x is probably the easiest because all the other ones are going to give you a little bit more of a headache. So I'm going to pick the 2x, and then I'm going to isolate for x. So that means I'm going to have to move that 3y over. So what's going to happen is I'm going to get that 2x still by itself equals negative 12. that 3y is going to now become, so that negative 3y is going to become positive 3y. And I still want to get x by itself, so I need to divide this side by 2, and I'll have to divide all of this stuff by 2. And what happens there, I get x equals negative 12 divided by 2 is negative 6, plus 3y divided by 2 is plus 1.5y. Okay, so here's my equation number 1, here's my equation number 2, and now I can take that x, I can put it into this equation, and I can solve. So I have 6x plus 5y equals negative 8. And now instead of x, I'm going to put whatever x is equal to, which is all of this stuff over here. 6 times x, x is negative 6, plus 1.5y, plus 5y equals negative 8. So I'm going to use distributive property, multiply that, multiply that. 6 times negative 6 is negative 36, plus 1.5 times 6 is 9y, plus 5y equals negative 8. And now we'll collect our like terms. We'll bring that 36 all the way over. 9y plus 5y is 14y equals negative 8 plus 36. So I get 14y equals 28. Divide both sides by 14. Divide by 14. And we're going to get y equals 2. Good. So I know that my y equals 2. Now I can take that and put it back into the equation that I already have set up that is isolated for x. So I'll say x equals negative 6 plus 1.5, but now instead of y, I'm going to use my 2 value here. So x equals negative 6 plus 1.5 times 2 is 3, so x equals negative 3. So those are my 2 points, which means if I needed to write that, negative 3, comma 2. So when you are using substitution, a couple things to keep in mind. Remember, I put brackets around. Whenever you substitute, you must use those brackets. It's always best to try to find which variable is easiest to isolate for. I saw that 2x is probably the easiest, but that's a pretty unlucky one. Normally you're given at least one that doesn't have a coefficient number in front of it. Okay? And then once you've solved for one, all you gotta do is substitute that back in and solve for the x. That is what substitution is all about. Let's take a look at elimination. When we are trying to eliminate something, we're used to the equation being in y equals mx plus b form. We call this slope y-intercept form. And that's good, but we also might see the equations written like 2x plus y equals 7 and x minus y equals negative 1. That's not quite slope y-intercept form, and in fact, for elimination, this is actually a better way to do it. This is how we want these things written. So for elimination, we must have our equations written like that. Must be written like this for elimination. Okay, and you'll see that 99% of the questions we give you for elimination, they are already written like this. So what does elimination do? Remember back in grade school when you were taking a look at like, okay, if I had to add 7 plus 3, you would draw like this line and you would like go 0 and you carry the 1 and you'd have 10. Yay. It's kind of like that, except we get to decide, do we want to add or do we want to subtract? So this is how this works. We take a look at what between these two equations, so equation 1 and equation 2, which variable is identical. And if you take a look, we have a y here and we have a negative y here. Those have the same number in front. They have a 1 in front, right? There's this little imaginary little 1 here and there's an imaginary little 1 here. And that's good. That's exactly what we want. Because if we have the same number in front, we don't really have to do too much work. All we need to do is decide, do we want to add or do we want to subtract? And so here's how it works. You add if you have different signs. You subtract if you have the same signs. So here we have different signs, right? We have a positive and a negative, so here we are going to add. So we'll put this little plus sign to our minus that we're going to add. And now you just add the columns. So I'm going to add 2x. So I'm going to add this one, and I'm going to add this one. 2x plus x, I get 3x. Positive y plus negative y, I'm going to get plus 0. And then 7 plus negative 1, I'm going to get 6. And the key is you need this to always be plus 0. That's the point of elimination. We're eliminating something. We're getting rid of it. We're getting it to be 0. So the whole point of this is to make that happen. We need to make it so that when you add these things or subtract these things, you get that 0. So now we can rewrite this. 3x, we can get rid of that plus 0 equals 6. And then we just divide. Divide by 3, divide by 3, and you get x equals 2. Sweet. So now what we'll do is we'll substitute that x equals 2 back into either of these equations. It looks like probably equation 1 or 2 might be easier. I'll just use equation 1 since it's the first one. 2x plus y equals 7. I'm going to take that x equals 2, substitute it back in, and solve for y. 2 times 2 plus y equals 7. So I get y equals 7, and this was 4. I'll bring that 4 over, and I get y equals 7 minus 4, which equals 3. So my final answer is 2, 3. Okay, so that's a nice easy one. Let's try another one here. Let's do... Okay, let's do 2x plus 5y equals 3. 2x minus y equals negative 3. Okay, so what are we going to do here? Well, remember, we need to figure out, are either of these things the same? Do either the x's have the same number in front, or do the y's have the same number in front? Well, we got lucky. Our x's have the same number in front. And they are both positive. And so if we look back up, this box here says if they are we're going to add if they are different signs. We're going to subtract if they're the same signs. These are the same signs, so we are going to use subtraction. So 2x minus 2x, that's going to be 0. 5y minus negative y. So 5 minus, there's an imaginary little negative 1. Sometimes with the subtraction, people get a little confused. You can use your calculator if you want. 5 minus negative 1, that's going to give me positive 6y equals 3 minus negative 3 is 6. So 6y, divide that by 6, divide that by 6, and you get y equals 1. And so see what we did there? We eliminated. That's what we want. We want to get rid of that thing. That means we are doing it correctly. Now that I have my y equals 1, I can put this into any equation and solve for it. So I'll put it back into the first equation. 2x plus 5y equals 3. 2x plus 5 times y was 1, equals 3. So 2x equals 3 minus 5, because I brought that over. 2x equals negative 2, divide by 2, divide by 2, and you get x equals negative 1. So my solution would be negative 1, 1. So we've done one with addition, we've done one with subtraction. Now what happens if we aren't blessed with a 2x and a 2x? What if we had a 2x and a 4x? Well, what do you do then? And for that, I'll show you. So for this, let's take a look at the next example. X plus 2y equals 2, and 3x plus 5y equals 4. Here we have a bit of an issue on our hands. We have an x and a 3x and a 2 and a 5, which means we can't use addition or subtraction because we don't have anything the same. So here's what we can do. We can either get our x's to match up or we can get our y's to match up. And what you do is you have to multiply all of equation 1 or all of equation 2 or sometimes both in order to make that happen. So let's say we wanted to get our x's to match up. What would I have to multiply equation 1 by in order to get the same number here as there is there? Well, of course, I'd have to multiply everything by 3. So if I multiply that whole equation by 3, then I would end up with a 3x there. What if I wanted to make my y's match up? Well, what would I have to multiply this 2 by? Well, I can't really, because how am I going to make it equal to 5? So what I'd actually have to say is, well, what number can both of these things reach? Well, they can both reach 10, right? If I take this equation and multiply it by 5, and I take this equation and multiply it by 2, then they're eventually both going to get to 10. But that seems like a whole lot of work when it was a whole lot easier to just multiply that first one and get our x's to match up. So we'll worry about just the x's matching up for now. So this one has x, this one has 3x. We're going to multiply this thing by 3. And when we do that, we get 3x plus, and now 2y times 3 is going to give us 6y equals 2 times 3, which gives us 6. So we just multiplied every single one of these pieces of that equation by 3. So that's equation 1. This is going to be equation 2, so I'll just write it over here so it's all in a nice row for us. And now our x's have matched up. This is good. So we need to decide, do we want to add or subtract? We have the same sign, subtract. Same sign, you subtract, so we will subtract. 3x minus 3x is going to give me 0. 6y minus 5y, that's going to give me positive y. And 6 minus 4 gives me 2, so I don't even have to do any math. My y equals 2 for that. Then I'm going to take it and I'm going to substitute it back into equation 1 or into equation 2, and it doesn't matter which one, so I'll just always pick equation 1. 3x plus 6y equals 6. Substitute this y back in. I get 3x plus 6 times 2 equals 6, and I get 3x plus 12 equals 6. Bring that 12 over. 3x equals 6 minus 12. 3x equals negative 6. Divide by 3, I get x equals negative 2. So when all is said and done, I got negative 2 and 2. Okay, and let's do one more here. So I'm going to pick a hard one. 4x minus 7y equals 19. 3x minus 2y equals 11. And so for the last one, I'm going to show you both substitution and elimination, and hopefully we get the same answer, although this one is a little bit tricky. So we can decide, okay, do we want to get our x's to match up, or do we want to get our y's to match up? What's easier? Well, there's not really an easy answer here. I'm going to get my x's to match up. So what's a number that both 4 and 3 can get to? Well, we can say 4 and 3, they're both going to eventually get to 12. So how do I make that happen? So for the first one, how do I get my 4 up to 12? Well, I'll need to multiply it by 3. And what happens there if I multiply every single one of these things by 3? Well, I'm going to get 12x minus 21y equals 57. And this one I need to multiply by 4 in order to get this up to 12. So 3 times 4 is going to give me 12x minus 8y equals 44. So I have my two equations, 1 and 2, and since I have the same sign for x, I'm going to use subtraction. 12 minus 12 is 0. Negative 21 minus negative 8 is going to give me negative 13y. And 57 minus 44 gives me 13. So I'll divide this side by negative 13, divide this side by negative 13, and I get y equals 13 divided by negative 13, which is negative 1. Good. Now I'm going to take that and I'm going to substitute it back into one of these equations. So I'll just substitute in the bottom one. 3x minus 2y equals 11. 3x minus 2, my y value is now negative 1, so I'll put that in there. Negative 1 equals 11. 3x plus 2 equals 11. Bring that 2 over, and I get 3x equals 11 minus 2. 3x equals 9. Divide by 3, and I get x equals 3. So when all is said and done, using elimination, I got 3 and negative 1. Now I'm going to do the exact same thing, but I'm going to try to use substitution. So let's try that. So again, I have 4x minus 7y equals 19, and I have 3x minus 2y equals 11, and which one's easier to isolate for? Neither of these are really great, so I'm going to pick this 2y here to isolate for. So I'm going to isolate for that. What happened there? I'm going to isolate for that. So I'm going to move this 2y over, and I'm going to bring that 11 over just so I can make that 2y positive, or else it would be negative. So 3x, that 11 is going to come over, so it's going to be minus 11, equals negative 2y now becomes positive 2y. And I'm just going to divide everything by 2. So I'll divide by 2, divide by 2, divide by 2, and I get 1.5x minus 5.5 equals y. So now I'm going to take this and I'm going to put it into this equation here. So I still have my 4x minus 7y equals 19, but now I'm going to put this in for my y value. So I get 4x minus 7 times 1.5x minus 5.5 equals 19. Okay, so you're probably going to need a calculator for this, and we get 4x minus, and now we're going to distribute that in. So we get minus 7 times 1.5 gives me minus 11.25x, and then minus 7 times negative 5.5. So I need you to think about that. So if you have minus 7 times negative, that means you're going to end up with a positive, and you're going to get positive 41.25 equals 19. So we get 4x minus 11.25x, so we're going to keep that on one side. We're going to move that over, and you'll end up with 4x minus 11.25x equals 19 minus 41.25. So 4 minus 11.25 gives me negative 7.25, and that's going to equal 19 minus 41.25, which is negative 22.25. Okay, perfect. We'll divide this side by negative 7.25, divide this side by negative 7.25, and when we do that, let's see what we get. So we get our x is about negative 3. Is that what we had before? Well, it is, but it's actually positive 3. I messed that up because we have a negative and a negative. That should give me a positive. So we are at positive 3, and that's good. So now I'm going to take this x value and substitute it back into my equation that I've already isolated y for. So that equation was y equals 1.5x minus 5.5. Take that 3 and plug it in there. Y equals 1.5 times 3 minus 5.5. So you get y equals 4.5 minus 5.5, and you get negative 1. So my points would be 3 comma negative 1. What did we have before? And we had 3 comma negative 1. So whichever way you choose, you are going to get the right answer as long as you follow the right steps. So try this homework. You might need to watch this video again. This is always a difficult lesson, so don't feel bad if you're struggling with it. Just stick with it. Watch those homework solutions. They're very helpful, and we'll go through this one.